Welcome everybody. Good afternoon once again. Right. So this demo, we're going to start with taking data from ERP system, right, and loading it into Delmia Ortems, which is the advanced planning and scheduling system. And from there, after we um, do simulations and adjustments and get a firm schedule, we're going to take that sequence production schedule and take it down into the Delmia Apriso manufacturing execution system. In the Delmia Apriso manufacturing execution system, we're going to be looking at how a supervisor is able to control what his people on the floor are going to do. Rather than flood them with a bunch of orders for the entire month, it's going to be very day oriented, right? And they're going to see only the orders that they need to produce for that day or for that shift. During this demo, you'll also see that we enforce traceability and quality inspection while getting data from machines and capturing all the data of machine, material, labor. With that, let me take you over to the demo. So the screen here, what we call as an interface configurator, is a screen that brings in all the master data from an ERP system and the orders. The master data has already been loaded. We're going to start with the orders. Okay, the loading has been completed. Before I go into the actual demo, I want to show a brief overview of what is being produced and what are the different operations or sub-assemblies that go into this production. So this is the final assembly. There's a final assembly operation followed by a packaging operation. Let me make this a little bit more visible. As you can see, there are a number of sub-operations and sub-assemblies that feed into the final assembly. So if I were to schedule this, just one order, it's easy. But if you have to schedule a similar type of products over a period of a month, it becomes very complicated. And that is where a solution like Ortems helps us, right? Because it will take into account all the sub-levels of a bill of material, right? All the operations that go into making a product, and will schedule based on customer KPIs. With that, let me take you over to the actual demo system. So these are all the orders that were loaded from the different ERP systems. So we have, starting from the week of November 21st, we have all the way up to December 12th. These are all the orders, different orders that have been loaded. Okay, with that, I want to take a look at, as you can see, the screen can be split into two different views. On top, I have the orders, and at the bottom, I'm looking at my machines and their capacity. Let me start with scheduling, only the final assembly. Okay. As you can see now, the final assembly orders have been scheduled. Now I'm going to let Ortems calculate all the sub-assemblies that are required to making this final products. And as a first check, what I would like to see is, are any of my machines overloaded? So switching from one view to another view in Ortems is enabled through macros. Right? So we have function keys on our laptops or keyboards. Right? So in this particular instance, I'm using my F1 function key to switch from the previous view to another view where I'm looking at all my operations at the top and my machine capacities at the bottom. Right? And from what I can see, none of my machines are not overloaded. Everything is around either 100 or below. Now, the second most important thing that I would like to look at is, are my customer schedules being adhered to? So for that, again, using another function key, I'm going to switch to a different view. And what we are seeing here is the coloring is based on whether there is an advance or a delay based on a customer due date. Just as an example here. So this was the customer due date, 11/28 to be delivered before midnight, and Ortems says we can deliver it on 11/28 at around 7:30. If there was a delay, these colors would have turned to red. Another important factor that we have taken into account is tool changeovers. Right? We know that most manufacturing assembly setup, when a product is being produced and we have to switch to a different product, most of the time we would use tool sets. Right? So in this model here, there are two factors that are very important. One is the customer due date. Second, minimize tool changeovers. As you can see here, the gearbox 12, one set of orders for gearbox 12, followed by another set of orders, followed by a third set of orders, and then there's a tool changeover because now we are going to start producing gearbox 11. Right. As you can see here, the first order that we're producing is 209-2004. And then we have 2. So what Ortems has considered here is the customer due date and minimize tool changeovers. For example, if I were doing this manually, right, and I had scheduled like this, now I've got two different tool changeovers, right, which is not the best thing to do. That's why we let Ortems do the scheduling based on criteria like customer due dates and minimize tool changeovers. Now the next important factor for me is, do we have enough material to produce? I'm going to switch to a different view now. And again, at the top of the screen, you're seeing all the operations. And at the bottom of the screen, now we have the raw materials. And there is stock, and we're looking at planned on hand. Here, what this means is the incoming advanced shipment notifications from your suppliers. And from what I can see, I seem to have a problem in the forged pinion on the 29th of November. So if I click on this box, the system is telling me, okay, this will be my starting stock, this will be the input, but we need 4,675 pieces. So I made a note to call my buyer and let them know they need to talk to the supplier and get them to ship in advance. Otherwise, we would have a problem on the 29th. With this, we all know that there are the 3 M's that are important in manufacturing: mission, material, manpower. So I want to look at my labor and see if we would have a problem. Using function keys again, I'll switch to a different view where we are looking at labor by skill, and we're looking at capacity minus load. So down here, the 0 here indicates that our load and capacity are equal, whereas on 11/22, I have excess capacity of 1%. 11/23, another excess capacity. So if somebody wants to take a vacation on 11/21, we would have to look for alternate arrangements. On 11/22, the same person wants to take a vacation. We would not have a problem, and we don't need to look for alternate arrangements. That's what I'm looking at in the screen. Okay. I don't seem to have a problem. Now, in all manufacturing facilities, there is always this planned maintenance, which is kind of pre-scheduled, but then there is always this uncertainty, which brings in unplanned maintenance. So something like that happens. And how do we tell our manufacturing people and our maintenance team that unplanned maintenance can occur without affecting manufacturing capacity? Okay, let's take a look at this machine here. At the top of the screen, you're seeing all the operations scheduled on different machines. On the bottom of the screen, we're looking at the capacity calendar. It's called the mission calendar, and that is what we're looking at. And let's say the unplanned maintenance is going to happen on this machine here, and they want to know that can we bring this machine down for 3 days, because that is when we plan to take care of the machine, because the supply is coming in and we will fix this machine. So what I'm going to be simulating here is, if this machine goes down, what is going to be the effect? Before I start the simulation, take a look at the right-hand top corner here. Okay. What this indicates to me is, right now I'm having a 100% service rate. My customer schedules are being met, and I don't have a delay. Now with this unplanned downtime that's coming into play, this looks really bad, right? At this time, I want to save this as a simulation. Now, what I can see is, yes, these operations, I can probably start moving them manually into similar machines which can perform the same operation, but then there's a lot of operation that I'll need to move, which is going to take a lot of time. Instead, I'm going to let Ortems tell us what is best, given the fact that one of the machines is going down because of an unplanned maintenance. Okay. So what Ortems has done is, it knows that there are no operations that can be run on let's do on days 11/21, 11/22, 11/23. So it shuts the entire line down and it moves the operations to similar machines that can perform the same operation. And if we look back at the KPI here, we are back at 100% service rate and there's no delay. Let me save this as another simulation. So I've saved the simulations and I want to see how they compare with each other. As we can see, simulation 1 was not the best option. It has brought a lot of red flags, whereas the original option of letting Ortems do the simulation has helped us. So this is another important feature within Ortems, where you can simulate different scenarios based on conditions, and then come up with the best plan that works best for everybody involved in the manufacturing process. Now, how do we send all this data to Apriso? Let's take a look at one of the missions here. I want to focus on the assembly line. So what you're seeing here is the sequenced production schedule for assembly line. As you can see here, it does not go by order number, right? It goes by based on the logic of meeting the customer due dates and minimizing tool changeovers. With this, I'm ready to scan my schedules to Apriso. At this time, I'm going to stop sharing my screen. And Ricardo, could you please share your screen and open Apriso?
Sure, let me start sharing my screen. Okay, so first, after we have received the orders from Ortems, we can see here where we're logged in as a supervisor. We have received here the first 3 days, the next 3 days. And this is the order we're going to be using for today's presentation. So the supervisor accepts the order. And at that point, you can log in as a production operator. Here, this is our operator console. And we can see that the order is ready. So if you try to start the order like this, the way the system is set up, it's not going to allow you because you need to scan the components you need to produce this piece.
This is our first step to enforce traceability.
So in the plant, the operators would have a scanner to scan barcodes, but here we're just going to copy the part numbers. And now we should be allowed to start the order. We can go to the report production screen, which is where the operators will be doing most of their work. And here you can see this is the piece, the unit that we're producing.
On the screen, there's a lot of other important data that will be very useful for a production supervisor or a production manager. Right? At the top of the screen, you see what is being produced and the order number and the quantity, and there's a lot of statistics about how much has been produced and how many were good parts, how many were bad parts, how many of them are waiting for inspection, right? And how many of them are waiting for the operator to take any actions. Right? And there is a picture that shows the product that is being produced, right? And there can also be operation manuals attached to the screen. Right? With this, let me start the production.
Okay. So as you can see, now we have 11 units in waiting. We're simulating the production has been completed, and now the operator can report if the unit is okay or not okay. So if they try, as you can see here, we have a startup checklist, which is required for the operators to be able to start working on the machine. And it's some basic safety questions like, are you wearing the necessary PPE? Have you tested positive for COVID? So once the startup checklist is completed, you can continue reporting production. And here is another quality check that we are enforcing for the first piece that gets produced. You need to enter some data.
And these quality inspections can be enforced as for every part number that is being produced, there needs to be a quality inspection. Or it can be just a first piece and maybe a scheduled inspection every 2 hours. that's a flexibility that Apriso manufacturing execution system brings to us. And as you can see on the screen, the inspection characteristics could be a simple yes or no, good, bad, or it can be measurable parameters.
Yes. So now you see the status for this part is good, and you can continue reporting production. But also, if one of the pieces has any defects, we have enabled here the visual quality defect tracking, which allows the operator to indicate what happened and in which part of the piece is the issue. So we can put one defect here, a displaced hole here, for example.
So rather than just saying, okay, put a rejection reason code and put a label on the bad part, Apriso allows us to mark where the defect has happened and what was the type of defect. The advantages of such a visual quality defect tracking system is a quality manager or a quality supervisor can analyze defects of multiple products over a period of time and determine if there is a problem in a particular area. That helps them to improve the product and the manufacturing process.
Yes. So as you can see here, we have a non-conforming part and the defects that we have reported for this order. And just really quickly, I'm going to complete production of one handling unit for you to see when all the serials get assigned.
And as you can see, while Ricardo's completing that, the statistics at the top of the screen are changing.
And you can see here, all the good serials have been assigned to one handling unit. And
each of these have a unique serial number, right? So that is that part label that's printed with the serial numbers and attached to the part, and the handling unit label gets attached to the pallet.
Yes. Now, if we go back to the supervisor screen, we can see the concentration diagram, which is a tool that allows us to see what Prabhu was saying about the quality supervisor being able to check for all the defects. We can see them here. Here the supervisors can see the picture of the product, and then they get a heat map of which issues are happening on which parts of the units, and that way they can know if there is anything in particular they need to pay attention to. And if anybody has any questions at this point, or can we continue?
Let's continue, Ricardo.
Okay, so with that, now I'm going to show you some of the reports and dashboards that Apriso offers. Here we can see the dashboard repository, and we have a quality dashboard.
So this is in addition to what the quality supervisor and the quality managers were looking at on the concentration diagram, which focuses on a particular product or multiple products. Right? This is more like a comprehensive summary of all the defects that are happening across the plant. Ricardo, let's take a look at one of the reports.
We have the EMR reports. Here we can see,
which is an electronic manufacturing record. Okay. That gives the entire history of how this product was produced, what went into this product, who are the people handling this product, and what are the different operations that were carried out, and what machines were they carried out with a timestamp, as you can see.
Yes.
Okay. Thank you, Ricardo.
Thank you.
Okay, so what did we see in this demo? Right. We saw the ERP orders integration to Ortems happening seamlessly. Within Ortems, we saw that Ortems was scheduling the orders based on various master data, the bill of material, routing, missions, inventory, labor. And we saw how the use of macros, that's the function keys, to check various scenarios without having to reconfigure screens every time we log in into this production scheduling system. We also were demonstrating how simulations can help in the event there is a problem in the plant. And Ortems monitors KPIs automatically. There are inbuilt KPIs, around 30 of them, and we can decide and choose what we want to see on the screen. At the end of that Ortems exercise, we saw that Ortems had a sequence production schedule, and for one of the missions, we took that down to Apriso, where we saw that traceability was being enforced before you could start the orders. Quality inspections were enforced, not waiting on somebody to take a decision on saying, oh, do I inspect this part or do I not inspect this part? And during the inspection, we saw that if there is a defect, we were using the tool Visual Quality Defect Tracking from Apriso. What we had demonstrated was a two-dimensional view, but Apriso is also capable of giving you a three-dimensional VQDT. We saw that the cycles that were coming up on the operator screen were controlled from the machine and not waiting for an operator to say a part has been produced. The operator's role here was to say if the part was good or bad and record any inspections. We saw how defect analysis can be done easily and seamlessly within Apriso, and we also had a look at some of the sample report or dashboards.